Okay, today we're going to go over this for Math 1, 10.1 task and warm-up. And the topic is graphing quadratics and using vertex form of a quadratic equation. So actually, this is the beginning of the task, but I'm going to start on the back page so that we can understand vertex form a little bit better. Okay, so the first thing that you need to understand is that quadratics have a parent function. Okay, so the parent function of a quadratic is y equals x squared. So that's like your basic starting quadratic function. That's the intersection is at 0, 0. And so if you were to sketch it, it would just look something like this. It has a curve. It has a curve going up, opening up. It has the vertex at 0, 0, the origin. And so if you understand what the parent function looks like, then we're going to discuss how vertex form shifts this parent function up or down or left or right, makes it more narrow or wider, or it can also flip so that it opens down and it has a vertex that's called the maximum. Okay, so this equation is actually the vertex form of a quadratic. So each of these variables has a different role to play in how you're going to change the parent function. So the first question is, what are the coordinates of the vertex of the parabola? So the vertex is where the parabola turns. So you can see that, the parent function actually, the vertex is at 0, 0. Well, how you can tell where the vertex is from vertex form is it's whatever HK is. So we're going to say HK. That's an ordered pair that whatever number is in here in H's spot is the X value. Whatever number is here in the K spot is the Y value of the ordered pair, the vertex. And then what is the equation of the axis of symmetry? Well, when you have a parabola, it's symmetric. So you have an axis of symmetry that is just a guide on how you would graph a parabola, but it's not actually part of the graph. But it gives you a guide because every point on either side is a mirror image of whatever is on the other side over the axis of symmetry. So the axis of symmetry, since it goes through the vertex, is going to be, okay, this is an equation of the axis of symmetry. And you know a vertical line is x equals, and it's going to be x equals, and then whatever the x value of the vertex is. So in this case, x equals h. And this will make a little bit more sense. I would write these down, and then this will make a little bit more sense when we practice it with numbers. So how can you tell if the parabola opens up or down? Well, that's the role that A plays up here in the vertex form. So if A is positive, if it's a positive number, then your parabola will open up like this. And if A is negative, it'll open down like this. Okay, how do you identify the stretch or shrink? This is called describing the dilation. That is, how do you determine when the graph will be wider than the parent function or narrower than the parent function? Okay, A also has this role of deciding whether the parent graph is going to be wider or narrower. So if the absolute value of A is greater than 1, like if it's 1.5 or 2 or -2, then the graph, the parabola that you're referring to from the vertex form, will be more narrow, because what's happening is your y is growing faster if the absolute value of A is greater than 1. And if A is like between -1 and 1, so if like a fraction, then the graph will be wider, because what's happening is your y is growing slower. So as you put x's in, since it's going to stretch sort of slower. How can you tell if the parabola will have a maximum point or a minimum point? So what it's actually asking for is, basically it's asking sort of the same question as C. So if it opens down, then it has a maximum point. And remember, that happens, it opens down when A is negative. And then it has a minimum point, right? Like right here. When it opens up, it has a minimum, and that happens when A is a positive number. Okay, so I would just write down those notes, and then we're going to just keep using the information that we get from vertex form to do some graphs. All right, so let's go back to the warm-up. Here you have two graphs of parabolas. One opens up, one opens down. You can see they sort of sketched in here the axis of symmetry. You have a minimum here at the vertex. You have a maximum here at the vertex. And it says, in your own words, define each feature of a parabola. Well, if it's in your own words and not like a technical math definition, you can say the vertex is where the parabola turns. It's an ordered pair. So this is a vertex. This is a vertex where it turns. Axis of symmetry is actually an equation, x equals something, where points on either side of axis are sort of mirror, you can say mirror images of each other. So if you know that you have this point on one side of the parabola, and then you have the axis of symmetry, it's going to be equidistant to the other side. So you know 2 points there. Minimum is the lowest point. This is when lowest point or vertex if it opens up, right? And obviously this is the highest point or highest vertex when it opens down. So right here. Okay, so there's a little bit of vocabulary that you could sort of define in your own words. All right, so let's go ahead and just practice using vertex form. It says use the function y equals quantity x minus 2 squared plus 3 to answer the question. Okay, remember our standard vertex or our general vertex form is y equals a times x minus 2 squared, x minus h squared plus k. All right, so this is your vertex form. So you're just going to plug in, it says, what is the vertex of the function? Remember, the vertex is hk. So in this case, for this equation, the vertex is going to be 2, 3. What is the equation of axis symmetry? Remember I told you it's going to be x equals h. So for this function with these numbers, it's x equals 2. What direction will the parabola open up? Well, A is right here, right? A is right here. So it must be 1. A is 1. So it opens up like this. You already know what it's going to look like. And complete the table of values and graph the function. Be sure to graph at least 2 points on each side of the vertex using symmetry to graph the parabola. So if you're going to fill out the table, this is like, this equation is a representation of the quadratic. This table is a representation of the quadratic. The graph is obviously a representation. So I would start my table with just putting in the vertex. So 2, 3, and graph that, right? 2 up 3. And then maybe I'll choose 1. Like if I plug in 1 as my x into this function, 1 minus 2 is -1. -1 squared is 1 plus 3 is 4. Okay, so 1, 4. And then remember, the axis of symmetry is right here. So actually, I could go ahead and plug in 3, but 3 is equidistant to the axis of symmetry as 1. So it's just a mirror image on the other side. So I already know that if I plug in 3 to this function, I'm going to get 4. So 3, 4. And then maybe I choose 0. So plug in 0. So 0 minus 2, quantity squared, plus 3. 0 minus 2, -2. -2 squared is 4, plus 3 is 7. So 0, 7. I'm going to go ahead and graph that. And then, again, I can use symmetry to graph it. So this point is 2 away from my axis of symmetry. So I know that there's another point, 2 on this side. So I already know that if I plugged in 4, I would get 7. Okay. So now what you want to do is just sketch a curve. So you just want to do the best to sort of connect the dots, but not in a straight line. So you want to just sketch the curve and just extend it with arrows, just saying that it keeps going on in that direction. Okay, so describe the transformations needed to move from the parent graph, y equals x squared, to the function that we just graphed. So like basically what happened that was different than x squared? Well, this -2, it actually shifted right 2. And from this 3, it shifted up 3 units. So see, the parent graph would have been right here. The parent graph would have been, something like this. But our new equation shifted it right 2 and upward. All right, let's practice a little bit more with this. So for each problem below, find the missing representations. Remember, I was telling you the equation is a representation in the table and the graph. So here we have a description, and we're going to write the equation, and from that we get the vertex, and we get the axis symmetry, and then we can make a table and graph it. So it says the area of a square with an original side x. So I'm just going to start with x. I have an original side x. That's I know that I'm going to square it, right? Because it has a side squared. Where that side length is decreased by 3, so -3. But remember, this is the area of a square, right? Multiplied by 2, so that 2 is over here, and then 4 square units are added to the area. This description will actually make a little bit more sense when we do 10.2. But for now, you just know that you have this vertex form. Okay, vertex. Remember, vertex is HK. So it's 3, 4. My vertex is 3, 4. And my axis symmetry is always whatever my h was. So x equals 3. Make sure you write that as an equation because it's actually a line. Okay, table of values. Remember I was saying I start with vertex. So 3, 4. And then I just want to find some other points. Here's my axis symmetry. You don't have to put this in there, but I think it helps, to use for symmetry. Okay, so maybe I want to see where is this at 0 if I plug in 0. So I have 2 times 0 minus 3 is negative 3 squared plus 4. So negative 3 squared is 9. 2 times 9 is 18 plus 4 is 22. See, that's not a really good point to choose because it's so far up. So I probably want to choose something else, something closer. So I'll choose 2. Like I can't even graph 0, 22, it's so far up. Okay, so I'm going to do 2 times 2 minus 3 squared plus 4. Go ahead and plug in 2 for my x. So 2 minus 3 is negative 1. Negative 1 squared is 1. 2 times 1 is 2 plus 4 is 6. Okay, this is good. I can graph this. 2, 6. And then I'm going to use, this point is only 1 away from my axis symmetry, so I'm just going to go on the other point. And I have 4, 6. All right, but I need at least 5 points. So I'm going to also plug in 1 and just see where is this at 1. Hopefully it'll fit. So 2 times 1 minus 3 quantity squared plus 4. So 1 minus 3 is negative 2. Negative 2 squared is 4. 2 times 4 is 8. Plus 4 is 12. Well, this only goes up to 10, but I can, try to graph it up here and then reflect it over here. I probably could have plugged in like 2.5, something like that. Okay, and then I want to just sketch a smooth curve. See how it's more narrow than the parent graph? The reason that is because A is 2. So remember I was saying like if A is greater than 1 or less than negative 1, then it makes it more narrow. All right, so let's move to this one. This one, I'm not given a description. I'm given the graph, so I have to take clues from the graph in order to write my equation. All right, so I know that my vertex is at 3, negative 1. So, and then my axis symmetry is x equals 3. You can see that right here. Okay, and then let's put in some other points in the table. Help us a little bit. Okay, so 3, let's see, what about if I put in 2? So 2, 1, 2, 1, 4, 1. Okay, because here's some points that I know. Where's another corner point? 1, 7. And also 5, 7. All right, so now I want to write my equation. So there's a couple ways you could go about doing this. But I think one of the ways, well, first of all, it looks pretty narrow, like more narrow than the parent function. So I'm thinking that A is probably going to be greater than 1. So what I'm going to do is I'm going to put this table. There's a couple ways I could do that. One way I could do it is I could say, okay, when x equals 3, here's my vertex. And to get to my next x, I have to go up to right 1, kind of like slope, up to right 1. Oh, well then that way I know that A is 2. But another way you could do it is you could put this table in order. So I'm going to just make a new table and make it 1, 2, 3, 4, 5, like put it in order, and then put my matching points. So when x is 1, y is 7. When x is 2, y is 1. When x is 3, y is negative 1. When x is 4, y is 1. When x is 5, y is 7. Okay, and then I can do what I did before when I was trying to find if something was quadratic or not in Module 9. And I can find the difference, right? So between 7 and 1, that's negative 6. From 1 to negative 1, that's negative 2. From negative 1 to positive 1, that's positive 2. From 1 to 7, that's plus 6. And then I can obviously I already know that it's quadratic. So I actually need to find the second difference. Okay, so between -6 and -2, that's +4. From -2 to +2, that's +4. From 2 to 6, that's +4. Okay, well, since my second difference is 4, remember when we were doing standard form and I told you that A is half of the second difference? So A is half of second difference. So that means that A has to be 2. So we found that with the table. We found that, counting from one point to the next. All right, so when I go up here and write my vertex form, I have y equals A is 2, and then x minus 3, right, because that's my h, quantity squared, and then k is -1. So this is my equation, -1. All right, a little bit more. All right, now I'm not given the graph, I'm given the table. So I need to use the table to write my equation. But something that I see in this table that, first of all, it's in order. So that's good, right? That it's in order from like least x to greatest x. And so I want to see where the y's turn. So notice the y's go 7, 2, -1, -2, and then back to -1, 2, 7. Okay, then I know that this right here is the vertex. Because -1 is halfway between -2 and 0. So I know that that's the turning point. Like it was going, the y's were going down, 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 down. And then they go up, 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 up. So this is the turning point. So my vertex is -1, -2. My axis symmetry then is x equals -1. Okay, so now I want to find out, well, I guess you could, well, you want to find out what A is, right? You could graph it and look at it, but I think we'll just use the table since it's in order to find the second difference. So this is -5, -3, +1, -1, +3, +5, so forth. That's the first difference, right? But then between here, -5 and -3, that's 2. This is 2. This is 2. This is 2. Okay, so my second difference is 2. So second difference is 2. So A is half of the second difference. 1/2 of 2. So A is 1. Okay, so when I write my equation, I need to put y equals, I could put 1 here for A, but really this 1 is not needed. If A is 1, you just assume that it's 1. And then x minus, okay, my h is actually -1. So if I wrote x minus -1, it's really plus, right? So x plus 1 because it's x minus -1. And then my k is -2. So here's my equation. And then all I have to do is graph it. So you could go ahead and graph those points and sketch a smooth curve. I'm not going to do that because you know how to graph points on the graph. Okay, let's look at this one. This one, we're given the graph, and we have to find all the other pieces. So one thing I know about my equation, one thing I know is that A is negative. And the reason I know that is because it's opening down. So A has to be a negative number, right? So I can go ahead and find my vertex because I can see it on the graph. -3, 4. So my axis symmetry is x equals -3. I'll go down like this. Right. And then I can fill out this table. So -3, 4 is my vertex. I want to find another corner point. Oh, -5, 2. And its reflection, which is -1, 2. And then I want to find another corner point. Let's start right here, -7, -4. And its reflection, which is 4, 1. 4, 1. Okay. Oh, actually, 1, 4. Oops. 1, 1, -4. Okay. All right. So I could go through, I mean, these, I could put them in order, but they're skipping by 1, by 2 or whatever. So I'm going to just use that method to find what A is by finding, like, from one point, I have -3, x is -3. And if I go to -2, I would go down 1, right 2. And if I want to go to the next x, I would have to go down 1, oops, so down 1, right 2, oops, right 2, and then down 1, right 2, oops, down, down 1, right 2, yeah, okay. So I know that if I have to go down, it's like I'm going down a half, like on the half point. So I go down 1, right 2. It's, or I could go down 1, right 2, and get back on my problem. Or I could go uh, from here. I could go, so I go down 1, right 2. So I know that my A is -1/2. Okay. So you could have also done the situation where you put the table in order and then you find the first difference and the second difference. But I just figured we did that on this one, so we'll just use the graph for this one. Okay, so I have x minus -3, so that's x plus 3, quantity squared, and then plus 4. All right, now you see how this is wider than the parent graph? That's one way that I knew it was a fraction. Okay, so let's practice this again. Let's see what we're given next. Okay, on this one, we're given the table, and we have to find all the rest. Okay, this is good. It's in order, so that's good. Notice how the y's are going up and then down. So I already know that it's going to look like this. So if I already know that it's going to look like this, I know that A is negative. And I have -6, -5, -4, -3, -2. It goes up and then back down again. This is my vertex. So -4, 3 is my vertex, which means that x equals -4. I'm going to go ahead and graph that. -4, 3, x equals -4. Okay, but I want to go ahead and find the rest of my equation. So I already know my vertex, which is -4. So x minus -4 would actually be x plus 4, right? And then plus 3. And then you could, we want to find out what A is, right? We want to find out if it's more narrow or whatnot. So since it's the order, I can just go ahead and find, I mean, I could graph it and count like I did on the last one, but let's just use the table. Since it's in order by 1. So -2 to 1 is positive, or -1 to 2 is +3. 2 to 1 is 1. 3 to 2 is -1. 2 to -1 is -3. And then my second difference is -2, -2, -2. Okay, So then A is 1/2 of -2, which is -1. So this, I already knew it was negative, but it's -1. You can put the 1 here, but you really don't need it. And then you can go ahead and graph it. Okay, so graph each equation without using technology and be sure to have the exact vertex and at least 2 correct points on either side of the line of symmetry. Then identify the features of the function listed. All right, so notice that this actually, I mean, if you want to look at the difference, like from y equals x squared, how is it different from the parent graph? Like, what is added or taken away or changed from the parent graph? Well, notice that it has a negative, so that means it's flipped, meaning it's going to go like this because the negative does that, negatively. And also, this +3, it means it's up 3, shifted up 3. But you could also rewrite it in vertex form. You put y equals negative, and then it's x minus 0, right? Because it doesn't have anything else in that quantity, +3. So I think when you rewrite it like this, it helps you to find the vertex. Although the vertex from parent graph, remember, is 0, 0. So if it's only shifted up 3, then you know that the vertex is 0, 3. You know the axis symmetry is x equals 0, the y-axis. And you can find some points. So I would start with 0, 3. Got that. 0, 3. And then maybe choose 1 to plug in. So -1 squared plus 3. So -1 plus 3 is 2. So 1, 2. 1, 2. And then its reflection over here. -1, 2. And then maybe a little bit further so that you get a good, like I wouldn't choose 2 as my next x. Maybe I choose like 3 so that I get like a good, really know where it's going. So I'm going to choose 3. Okay, so 3 squared is 9. -9 plus 3 is -6. So 3, 1, 2, 3, 4, 5, 6. And since this is my axis symmetry, I can count 1, 2, 3 to my axis symmetry, and then 1, 2, 3 on the other side. 1, 2, 3. So also -3, -6. And then you could sketch a smooth curve. Sometimes when it's narrow, it's hard to see, like get the curve there instead of a point. So does the graph have a maximum or a minimum point? Well, it has a maximum for 2 reasons. One, it opens down, and 2, A is negative. So both those reasons show you that it has a maximum. What's the domain? So domain is always x's from left to right. Like how far, if this continued, how far to the left would it go, and how far to the right would it go? So it would go from -infinity all the way to +infinity. And then the range is always how low will it go wise, like from y's, and then how high will it go for y. So you know that if it keeps going, it's going to go to -infinity, which is parentheses, and it goes all the way up to 3. So 3 is included, so I'm going to put a bracket because that's inclusive. Okay, so remember domain is x's, and range is y's. We have, a little bit more practice. All right, so on this one, we're given the equation, which gives us a lot. It's in vertex form, right? So don't forget, it's a times x minus h, quantity squared plus k. All right, my vertex is actually h, but remember, vertex form is x minus h. So if this says plus 2, then h must be negative. H has to be equal to negative 2. So that means my vertex is actually at negative 2, negative 5. My axis symmetry is x equals negative 2. And then I could fill in the tables. So I have negative 2, negative 5. I'm going to go ahead and graph that. And then maybe I choose 0. I want to know where it is when x is 0. So 0 plus 2 quantity squared minus 5. So this is 2 squared, 4 minus 5, negative 1. So 0, negative 1. And remember, this is my axis symmetry. So instead of plugging in another point, I can just use symmetry. So this is 2 away from the axis symmetry. I can go 2 on the other side. So negative 4, negative 1. And then maybe I choose 2 as my x. So 2 plus 2 quantity squared minus 5. So 2 plus 2 is 4, squared is 16, minus 5 is 11. That's not good. I can't fit it. But it's really close. So I'll do 2, maybe 11 is up here, and then a reflection on the other side. So maybe I should have chose 1. So 1 plus 2 quantity squared minus 5. 3 squared, 9, minus 5, 4. So 1, 4. And then it's 1, 2, 3 away from the axis. So 1, 2, 3 on the other side is negative 5. Okay, so I have some good points to use to graph. Does the graph have a maximum or minimum? Well, you can see it has a minimum. See, the vertex is at the bottom. Domain pretty much for quadratics is always negative infinity to positive infinity because it's going to keep going outward. And then range from the bottom to the top. Well, my lowest y is negative 5. It's included, and it's going to go all the way up to infinity, which is always parentheses. All right, one last one. You already know it's going to be narrow because A is 3. It's going to be super skinny. Your vertex is 1, negative 2, right? H, K, your axis symmetry, x equals 1. And then you could go ahead and graph it, but A is positive 3. So you already know it's going to look like this. So A is positive 3. That means it has a minimum. The domain, negative infinity to positive infinity. And then the range, it's going to go from the vertex, which is 1, negative 2. And then it's going to, continue up. It's going to be narrow. I mean, I'm just going to sketch it. But you could actually fill in the points. So the range is going to be the lowest y, which is negative 2 inclusive, all the way up to infinity. Okay, so hopefully that helps you to go back and forth between a graph and a table and vertex form. Just make sure that you have these notes about vertex form written down because this is sort of your key to using vertex form. All right, hope that helps, and hope you have a great day. Let's see how I can change this. And